learners and science enthusiasts. Welcome back again to my channel. To those who are new here, please don't forget to subscribe or share my YouTube channel, and don't forget to click the notification bell so that you will get updated on my latest upload. So today we will be continuing our discussions about forces and motions. So the last time we discussed about uh, balance force, and one of the concrete examples of the balance force, let me get here materials. So this is the box, and then if you notice, the box again is at rest, and in this way the force is balanced because the normal force and the force of gravity counteracting on to each other, that makes this object or box at rest. But if you apply a certain force, either pull or push, so the box will move because of the other forces involved. Now, we will be discussing today about the unbalanced force, since balanced force is already clear to us. Now, try to imagine the ball on the table. So if you place the ball on the table and push it gently on the other side, observe the motion of the ball as it roll on the desk. So eventually, if you apply a little force, or yeah, if you push the ball, it will roll. So in that way, the force of gravity and then the other force, which is the normal force, are acting on the ball. So while the ball is rolling, so uh, in that scenario, the forces is balanced. All right, but if you take a look and take some time, the ball will stop. What do you think is the reason why the ball will stop eventually? Is there any idea? Great. So the one that is in your mind is correct, because there is another force that counteract on any movement. All right. So in your lower grades, you learn about fraction, and this fraction in general acts on the opposite direction of the motion. So for example, yeah, the ball. So when you push the ball and then it will rolls down, on that way the force is now balanced. But there is an unseen force, we call it fraction, which is acting on the opposite side, against the ball. Now the ball will stop because the fraction is counteracting on the opposite side, and because the forces, because you only push the ball once, then it makes the ball rolls on the desk, and after that it will stop because of the forces of the fraction that is counteracting against or on the opposite side of the ball. Alrighty, so again, due to the unbalanced force, the object change in its state of motion, hence we say it accelerates. So remember guys, that acceleration is not only change or increase in velocity, but it is also referring to decrease in velocity. Now, let us going to combine these two forces together, the balance and then the unbalanced force. So we combine or add forces to determine the next or balanced force. We will limit our discussions to those forces which acts along the same line of action. So let us have some kind of mathematical expressions on this topic for you to understand well, because it's very hard, really, just to make some kind of imagination. But let me show you the mathematical expression, especially the algebraic expressions of these forces. How are we going to calculate? So let me grab my whiteboard and the pen. Alrighty, so here we go. So let us have some kind of algebraic expressions on the interpretation of these forces. So we have the algebraic expression positive, and then we also have the algebraic expression negative. So these two signs are the symbols for the counteracting forces in the nature. Okay. All right. So if you still remember our examples, well, with regards to the book, so we have here the book and then the table. So the force of gravity, which is which the direction of the force of gravity is towards the center of the earth, so that's negative. And then the other one, the natural force, which is a positive, is counteracting on the force of gravity, which we call it the normal force. So this makes the book at rest because the force is balanced on this manner. Okay, so again, this algebraic expression of the positive and negative, these two opposite signs uh, is expressing or interpreting the the opposite directions of the forces, which occurs usually or basically in the nature. All right, so again, that's the mathematical or algebraic expression. So let us have a short example why the object is at rest if the force is balanced. Okay, so let me go ahead and check this out. So again, let us have uh, the expression Fn, or the net force is let us go back on our example on the about the book, which is lying on the table. So again, this is the force of gravity, which is represented by Fg. This is negative, and then the other force, which is the normal force, which is F, and this is positive. So counteracting on each other, the reason why the book is at rest. So let us have some kind of computation. So for example, let us compute or calculate the net force, and then the Fg is the force of gravity, and then the Fn, this is the normal force, all right. Yes, so given the force of gravity is equals to 3, and then the net force is, or the normal force is also 3. So if we're going to calculate the net force, so that means F net is equals to the Fg, which is the force of gravity, and then the normal force. So we have our force of gravity is negative 3 plus the 3 also for the normal force. So which means that the equation will give us zero answer. So which means the force is balanced. That's the reason why the object is at rest. Right. So you already found out through this um, exp, um, mathematical representation why the object is at rest, because the forces are balanced, both the by giving you the example on the force of gravity and the normal force with the same and equal forces applied. That is on the case of the balanced force. Now let us have the equation for the unbalanced force. All right, so this is the concept for the unbalanced I'm sorry. So this is the concept for the unbalanced force. For example, this is the box. Okay. Yeah, I apologize for the drawing. All right. So for example, this is the box, and if this is boy 1 and boy 2, so if boy 1 applies, for example, uh, 10 unit of force, and boy 2 apply 5 unit of force, so the net force here is, let us calculate. So boy 1, so that's 10, f1, that's 10, so and then f2, so this is like, this is force 1, which is represented by boy 1, so this is 10, and then the force 2 represented by boy 2, this is 5. So the net force in other word is 5, 10 minus 5, so that is actually 5, meaning to say, if boy 1 will apply force with 10 unit of force on this direction, and the boy 2 will apply 10 unit of force in this direction, so where do you think the object will go? Of course, by looking into the presentation, the object will go through in this side, because boy 1 apply more unit of forces than boy 2 already. So yeah, I think everything is now cleared. So the example that I have given to you about the balanced force and then the unbalanced force that is presented in mathematical equation is now cleared, why the object will remain at rest or why the object will continue moving. And again, as a short recapitulation, so balance force, when the equation gives you a zero result, and the unbalanced force will give you, it's either a positive or a negative result on the equation by calculating the net forces that is acting on each other. All right, so again guys, the basic concept here, you should understand the principles behind the Newton's law of motion, which is very significant in understanding the motion of objects in our universe. In our next topic, we will be discussing about the laws of motion. For your benefit, please do an advanced research on the Newton's laws of motion. There are actually three universal law of motions, authored by Sir Isaac Newton. So I would suggest to read that, so that once you get back for the next lesson, it's more easier for you to cope with our discussions. Again, don't forget to subscribe and click the notification bell on your YouTube account, so that you will get notified on my upcoming videos, and please share also this video to your friends. Thank you so much, and this is Edward, and see you on the next lesson.